So today we're going to be doing the physics term 2, week 1 AMS quiz. It's a repeat of the last week of last term's quiz. Anyways, let's start. You're testing the conduction of 3 different materials by sticking them to a Bunsen burner and on rods by wax. So it means that the cork will fall off the one which has the best heat first because it's conducting best. So we know that first cork will fall off the best conductor, right? The best conductor here in our case is copper. Then the second best is gonna be steel because it's another metal, and the third is gonna be the worst conductor, fiberglass. Usually metals tend to be better than glass. Now, the factors that the rate of conduction depend on are the higher the difference between the two sources. So let's say you have a source that's 10 degrees Celsius and you have a source that's 90 degrees Celsius. The difference between this, it's gonna be a higher heat loss from this to this. But whereas when you have, let's say 50 and 53, there's gonna be less heat loss. Maybe the difference of heat loss might be like there might meet in the middle at 51 or something like that. So that's why. And the poorer the conductor, the better it insulates. If it's a poor conductor, it's a good insulator. And if it's a bad conductor, if it's a good conductor, it's a bad insulator. With the thicker the insulator, the slower the rate of heat loss. Because a thing like this, or a thing like this, heat will pass through this way more easy than it passes through this. So that's why. The smaller the area where through the heat that can escape, the smaller the area, the more heat? No. Thinner insulator better? No. Next question. Okay, so insulation should always be cheap and effective. The rest are wrong. During convection, by the way, the part has to be fluid. What does fluid mean? Liquid or gas? It has to be a liquid or a gas to undergo convection. It becomes less dense and floats upwards. Okay? So now we have radiation. Radiation from hot bodies can travel through empty space. This is a fact, we need to memorize it. Only hot bodies radiate energy. This is definitely wrong. All bodies radiate energy. Only cold bodies absorb energy. No, all bodies absorb energy. Energy lost by a body is emitted in portions called quanta. This is a thing you have to remember. I can't really explain it. Quanta is the portions that energy is transferred in. So this is correct. Radiation can be defined as the flow of heat from one place to another by the means of electromagnetic waves. Yes. If you remember when we took in chapter 8 types of heat, radiation was one of them in the form of infrared. All of them were radiation, by the way, microwave radiation, and they're all types of electromagnetic waves. Moving on. Conduction is the flow of heat without any flow of matter. This is a definition, we need to memorize it. The poorest conductor, here you had a long list of solids and then you had water. Water is a liquid. When it comes to conductors, solid, liquid, gas. Solid being best, gas being worse. So on a list of options, you had solid, 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 and one liquid. You're gonna choose the liquid as the poorest. But if there was a gas, you choose the gas. The states of matter that convection only happens in fluids, which are liquids and gases. We took this before. Now moving on. When a part of a fluid is heated, it becomes less dense, so it floats upwards, and other denser parts sink down. So this results in that upward and downward lateral currents of fluid movements are created, called convection currents. Whenever you see the word currents, lateral and convection currents. Moving on. Okay, so now we're comparing convection here. So let's look at the diagram and forget the question for now. So you have a lighted touch paper. It's gonna have air. When air becomes colder, it becomes more dense. Like when you have an AC at home. Why are ACs always placed up and the radiators always placed down? It's because when ACs release air, cold air is dense, so it's gonna fall down. But when radiators release hot air, it's less dense, so it's gonna go up, displacing the different temperatures of air. So here you have a touch paper that was lighted, but now it has to cool down, so it's gonna go downward, becoming more dense. It's gonna go in a current, and then it's gonna come here in front of a candle. What is the candle gonna do? It's gonna heat it, right? So when the candle heats it, it's gonna become less dense and go up. The arrow pointing down shows cold air, and the arrow pointing up shows hot air. It's logic. Now, let's see. In figure 1, okay, look, I have a simple way for this. Look, where is it coming from? If it's going from sea to land, sea breeze. Land to sea, land breeze. That's all you have to do to remember it. See? Coming from the sea, sea breeze. Coming from the land, land breeze. To stop convection, insulators with very small air bubbles. Because look, if you have a sponge, it has air bubbles, or it has little holes like a sponge does. Okay? Convection happens through air. So if you have little convection currents here, they're too small to happen in this small space. So they'll happen on a very small scale, and the more air bubbles you have, the more small scale for convections happening that gets stopped by how small the space they're convecting in is. So when you have more air bubbles, it's stopping the convection. It's more insulating. That's why sometimes when you see they put some hot drinks in styrofoam, it's because it's an insulator. It doesn't let the heat reach you. Okay. Max Planck came up with the idea that energy lost by hot black bodies is quantized, which means it's sent in quantas, which like we said in a previous question, are small packets of energy that are released. The frequency F, they want the relation between the energy of each quanta and the frequency. E equals Planck's constant times F, the frequency. It's a formula, memorize it. Okay, the best absorber of radiant heat is a black body. Memorize. Here we do what we said. E, energy, equals H, frequency. H is a constant. It's this number always, unless they give it to you like rounded up more, times the frequency. Do it in your calculator. 6.6 times 1 power 2, 1.2 is 7.9, times negative 34 plus 15 is negative 19. And that's it. Okay, here we have a thermocouple. What does it measure? Temperature. This is a known. Which ones are the same material? Y and W, because as you can see, they're kind of the same thickness on the picture. So they're the same material. What does meter X measure? This is a galvanometer or an ammeter. It measures current. Which one correctly describes a thermocouple? These you have to memorize because they're like part of the definition of a thermocouple. They have low heat capacities and the high precision. And they can measure all temperatures. And they have fast response to temperature change. So this is wrong, this is wrong. And we already said they have low heat capacities, so this must be low. So this is wrong, and leaving these two to be the only correct options. Okay. By the kinetic molecular theory, Heat transferred by conduction occurs when faster moving molecules in hotter parts. Always, when you see faster, it's hotter. Slower is colder. And they're gonna be colliding with each other. So they're gonna reach equilibrium heat. They're gonna reach the same heat. And this is transferring kinetic energy. That's how they transfer the heat with them. Okay, so we know that when you heat something, it expands. And when you cool it, it will get smaller. It will contract. So if you want to fit this cylindrical hole, this sphere in a cylindrical hole, you could try cooling it to make it smaller. Because cooling shrinks the sphere. That's what you're going to try to do to fit it. And let's see. Okay, so here you have an experiment and it's asking you, do you know which one's the best thermal conductor? Some people might think it's when the match lights on fire. No, but how is it gonna light on fire? It's not, matter isn't getting transferred as we know. It's only the heat getting transferred. So if you have heat transferring from here to here, what's gonna happen? It's only gonna melt the wax that's connecting it, because they're all waxed on one end. So the one that falls off first is the one that's the best conductor. See? The one that loses its match first. Okay, last question. Heat radiator is placed between a white and black surface. Okay, whenever you see better absorber, black. Better emitter, black. Better reflector, white. Better absorber, black. Better reflector, white. Better emitter, black. That's it for this quiz. Hope you understood everything. Have a good day. Bye.